Okay, we're talking about solutions, mixtures, types, parts, and solubility. This is chapter 16 in your textbook beginning on page 518. So the big idea is how can we classify different substances? So we're going to use their physical and chemical properties to help us decide where they go. So matter can be broken down into two categories. We have our pure substances on this side, and that's what we've been talking about all year. Our elements that make up our compounds, talking about our atoms, and then it keeps breaking down. So usually we started out talking about our elements, which are made out of atoms, and then we combined those elements into compounds when we did our naming for ionic, metallic, and covalent for it. Then our matter can also be broken into mixtures. So whereas pure substances, aka our compounds, are going to be a chemical bond between the two, our mixtures are going to be a physical bond. And we're going to break it down into two categories today, homogeneous and heterogeneous for it. So, what is a mixture? Well, we're going to see that a mixture is a physical blend of two or more components for it. So, we can look at solution mixtures like our Kool-Aid here, or we can look at a physical mixture or blend of this trail mix for it. So there are two parts to a solution. We're going to see our solute is the dissolved part. So in this example, if we're making salt water, we'll see that the solute solid will be our dissolved particle. And then we'll see the other part of the solution is our solvent, aka the dissolving medium. And in this example, our solvent or the universal solvent is water, H2O for it. So to make a solution, you have these two parts. Now, your solute could be a solid, liquid, or gas. We're primarily going to look at solutes when they are in the solid form. So our solid dissolves in our water, our dissolving medium, our liquid, and then it makes a solution, a physical blend of the two. So, what is the solute for example number one? What is the solvent? And then what is the solution? So, underneath your notes, you have each part for it. So, take a moment, pause the video, come back to it. In number one, we're going to see that our solute is going to represent that green powder. We're going to have our clear liquid as our solvent, our dissolving medium, and then we'll have our green solution at the end. So pause, try number two. We'll see our solvent is the orange liquid, and then we'll see that we have our blue solid is our solute, and then it equals our solution. So when making these solutions or physical blends, we need to dissolve our solute in our solvent to make a solution. Now, there are two different types of mixtures. Our first one we're going to look at is homogeneous, or sometimes we say homogeneous. So remember that the root word homo means same when we're in our chemistry and biological studies. So remember, a same mixture throughout. So we like to say that they're evenly distributed and they have one uniform phase. We can also call them a solution. So we do use the broad term solution with these different solutes in our solutions, but we can also call something like our Kool-Aid a homogeneous mixture because it looks the same from the top to the bottom. So we would say this is a Kool-Aid solution, or we could say a Kool-Aid homogeneous mixture. Now the opposite is hetero. So remember that the prefix hetero means different. So it means it's going to be different throughout. They're not evenly distributed, and they have more than one phase. So if we see our trail mix and we actually put it into a cup or container, we could have our almonds, our raisins, our M&Ms, our cashews, and we could see all these different layers for it. So what is meant by the word phase on the last slide? So a phase is just a uniform composition and uniform properties. So if we take a look at our solution here, we're going to see how many phases does it have. So we're going to see it has our top phase, which appears to be oil, and then it has its bottom phase, which is probably color, food dye in water. So we're going to have two phases in this because we can see two distinct layers for it. Now, if a mixture is physically combined, then we would be able to physically separate it. So how can we separate it? Well, our homogeneous, we're going to use the form our the process of distillation. So what it does is that it uses our mixture here, remember our solution, and then we have our hot plate underneath. As it heats up, we're going to be going from our liquid to our gas. So we'll see our gas raises up. Now these hose are going to put cold water in it, so then it's going to go from a gas to a liquid. So we use evaporation from our previous lessons, and then this is a condensation tube. And when it condenses, it's going to have pure water coming out. What's left behind in that beaker is the residue of the powder, the Kool-Aid powder. Now, our heterogeneous is a little bit different. So remember that they have distinct phases. So they're going to use physical means such as filtering, sifting, picking out the pieces. If you've ever gone to the beach and you had a sifter and you're looking for something, you have done the physical process for a heterogeneous mixture. Now, certain filter papers can pick up things, so notice that our mixture had red and blue, and only blue was able to go through it, meaning that in here we would have all those red particles for it. So, lesson check number 1, you might want to pause the video right now and then come back and check your answers. So decide whether the following would be homogeneous, and for homogeneous we're going to write HO, and for heterogeneous we're going to write HE. So a saltwater solution. The solution really gives us the key for what it's going to be. So our saltwater solution is going to be homogeneous. The particles are small and you won't be able to see them throughout. We have Lucky Charms cereal. We can see that there's different cereal pieces, there's different marshmallows. So we would say that's heterogeneous. If we added milk in there, there's another layer or phase to it. Sterling silver. So if we take a look at this ring, we would want it to be the same or different throughout. The same, awesome. So we're going to have HO for that. Orange juice with pulp. So if you've ever seen orange juice in maybe a clear container like those Simply Oranges, you can see all the pulp on the bottom. So we would say that there are 2 distinct phases. It would be HE for it. And then hot tea. If we take a look at our hot tea, the whole goal is that we want it to be uniform throughout. So we would see that hot tea is going to be HO for it. So that takes us through the broad definition of homogeneous and heterogeneous. So we had saltwater solution, sterling silver, and hot tea as our homo, meaning the same, and our hetero was our Lucky Charms, our orange juice with pulp, and only 2 for that one for that. So other types of mixture is the last thing we're going to talk about. So metal alloys are a mixture of metal like that sterling silver. We say they're homogeneous or homogeneous because they're uniform throughout. So brass is actually a physical mixture of copper, zinc, and lead, but brass has that nice gold tone to it. Now, suspensions, like our orange juice and pulp, has the largest solute particles, and we'll see that they settle out over time. And we can see it in this little glass that has sandy water or clay water. We can see that the particles eventually come to the bottom. Now, it kind of looks muddy or murky on top, but as time happens, those particles head to the bottom for it, and you'll see distinct layers for it. Now, our last one is our colloids. Our colloids are going to have medium particles as compared to our suspensions, and they have a cloudy look to them. So if we take a little bit of milk and we add water in it, it has that cloudy exterior to it for it. So these are the other types of mixtures that we can look at. So we have our big homogeneous and our heterogeneous. Then we have our metal alloys under our homogeneous. Then our suspensions and colloids underneath our heterogeneous. So thanks for watching and have a great day.